Hello everyone. So the topic for today is matrices. So now in matrices you need to know four things. You need to know how to add them, how to subtract them, and how to multiply them. There is no division in matrices. In matrices we take inverses. And when we take an inverse, we automatically divide. Now here for example is a quick example of how we multiply in matrices. In matrices we add in matrices. In matrices we need to add 2 with 3. Basically in matrices we need to add things at the similar positions. So for example at the first position we have 2. We'll add this 2 to 3 which is at the first position in this matrix. We'll add this 1 to this 1, second position into second position, the third one into third one, and the fourth one into fourth one. So the answer would be something like this. 2 plus 3, that would be 6. 1 plus 1, that will be 2. 0 plus 2, 2. And 3 plus 0 is 3. And that is how you add in matrices. The same goes for subtraction. Subtraction is done in a similar way. Now how do you multiply? Taking the similar example, in matrices we need to multiply in a different way. In matrices we multiply columns with these rows. Columns with these rows. So this thing will be multiplied with this row. This column will be multiplied with this row. So this is going to be something like this. 2 into this 3. And we need to add them into 1 into 2. Leaves a space, 0 into 3. Now we're at this one. Plus 3 into 2. The same goes for... So we were talking about multiplication in matrices, rows with columns. These rows with columns. Let's do this. That's 2 into 3. And that is 1 into 2. Then we'll leave some space, and that is 2 into this 1. Plus 1 into the 0. Into 0. Now we'll move on to this column. 0 into 3. 0 into 3. That's 3. Plus 3 into 2. That's 6. Yeah. So 0 into 1. That is 0. Plus 3 into 0. That is 0. Now we'll just solve them. So since we know the 2, 3 is 6. 6 plus 1, 2 are 2. That is 8. 6 and 3, that is 9. 2 into 1 is 2. Plus 1, 0 are 0. So 2 plus 0 is 2. And 0 plus 0 is 0. That is how you multiply in matrices. So here I have some simple past paper questions. Let's solve them. So it says that express A minus 2B as a single matrix. Now we'll write A. Minus 2 into, we'll write B. Now, in matrices, we need to multiply this 2 with this matrix. But it is very important to understand that we will never multiply this minus with this matrix. We'll minus these two answers. We'll not multiply this minus within this matrix. So this is going to be something like this. There you go. Now we'll subtract these two matrices. We will not minus this. We will not multiply this minus with this. So 0 minus 6 is minus 6, minus 2 minus 4. That is minus 6. 1 minus minus 2. That is 3. And 3 minus 0 is 3. Here. So this time it says that we need to find a raised to power 2. In matrices, we will never take a square of this thing. This is a. Okay. This is a. We will not take a square of this one. We'll write it twice and then we'll multiply it. So this is going to be something like this. 0, 1, minus 2, 3, 0, 1, minus 2, 3. Okay, we'll write it twice and then we will solve it. We will not take a square of this. We will never take a square of this. So this will be 0, 2, and 0 minus 6. This will be 0 plus 3. And this will be 1, 2 are minus 2 plus 3, 3 are 9. Notice that I multiplied them in columns with rows. Columns with rows. In column, row, column, row. So this will be minus 2, 3, minus 6, and that will be 7. Okay. So this question says to take an inverse of A. Notice that inverse is always represented in this way. This is a sign of inverse. It shows that we need to take an inverse of this matrix. So how do you take an inverse? The formula to take an inverse is adjoint over determinant. That is how you take an inverse. Adjoint over determinant. So now, how do we take an adjoint? In order to find an adjoint, we use this matrix. Now, when we are taking an adjoint, we need to change these values with their positions. So for example, there's written 4 and that's 0. We'll write 0 and 4. We'll change their position, nothing else. And second thing that is very important is we need to change the signs of these two values. So for example, if there's written minus 1, we'll write 1. And there is positive 2, we'll write negative 2. That is adjoint. As far as determinant is concerned, determinant is diagonally multiplying them and subtracting them. So determinant is going to be something like this. 4 into 0 is 0 minus 2 into 1 is minus 2. So this is going to be plus 2. That'll be 2. 2 is our determinant. Now we need to divide this adjoint with this determinant. So this is going to be like this. So the inverse will be, hold on. Yeah. So the inverse will be 0 divided by 2 is 0. 2 divided by 2 is minus 1. Minus 2 divided by 2. 1 divided by 2 is 1 over 2. And 4 divided by 2 is 2. Yeah. So this is the inverse of A. That is how you take an inverse. Adjoint over determinant. An inverse of A. So guys, the final question for today. Now, this is another past paper question. It says that AY is equal to this. Find matrix Y. Now, since we know that A is equals to this is how we'll do this question. We need to make Y the subject of this one. So we'll be able to find the inverse, so the matrix Y. So this is going to be something like this. Inverse of 1, 0, 0, 1. Okay, it is very important to understand that in matrices we don't divide them. We're not going to divide this A with this, because in matrices we can divide, as I've mentioned earlier. We need to take the inverse of this A when something went from this to this side. When we shifted A from this side, we'll take an inverse of it. We will not divide it. And secondly, the most important thing, as you know that A is first. It is, it is before y. As you can see, a is written before y. Therefore, will take an inverse of a. We'll write a before this matrix. A is written before y. We'll write this a before this matrix. I'm writing a before this matrix. Now I'll solve this. Now, since I've already taken the inverse of a, here's the inverse of a. I'll write it as it is. So it's just going to be something like this. Now I need to simply multiply these columns with these rows. These columns, then with these rows, then these columns with these rows, and these columns with these rows. And we'll get our answer, whatever that might be.